Okay guys, welcome back, and in this video we are going to be looking at the concept that separates beginner developers from advanced React developers. In this video we are looking at how to work with data, state management in React. So this is a very important concept, and once you learn this concept your whole React game becomes very easy. So I'm going to explain this concept using a simple performant application which I developed. So we're going to be going through some general React concepts, and we're going to be looking in particular at the context and hooks, because context and hooks are what we use to manage state in React basically. We are going to be interacting with an API, and I just use JSON server as a fake REST API that we're going to be interacting with, but the concepts in this tutorial are very solid. So I'm going to see how to manage state in your application. So the application I used for this was an e-commerce application. So a simple e-commerce application. So we have just three pages here: the home page, your cart, and your cart history. So what happens is, in this application, the home page, you can add different products to your cart, as you see here, and the products are added to your cart instantly. Then you can pay for those products in your cart, and they are going to be added to your history. So it's a simple application. You can search for products. Let's say we decide to search for phones. You see that it filters and leaves only phones. We decide to search for laptops. It filters and leaves only laptops. We decide to search for, let's see, oils, not oils, which other products. So you get the idea. You search, you filter. As you search, it filters and it leaves only the particular. You can add an item immediately after searching for that item. You can add the item to the cart, and you see that the state of these different actions down here changes, and the item has been added to the cart. And that's very interesting. Notice that if I pay for these items, it's just going to add them to our history. So here you notice that it tells you have three different products. It calculates the price of those products and gives you the total price. And as you change the quantities here, it changes in real time. Notice the quantity changes here in real time, and the total cost also updates. And when you pay for a product, it's going to consider that date. So you see that this date, I did this in the past, and if I just pay now, it clears our card, and our history now is going to have those three different items. And today is the 22nd. It shows that date and the total cost added to the history. So what's also interesting is that if we refresh here, if we refresh our application, notice that the history is persisted. So the history is actually saved, and refreshing the application does not clear, and everything is actually very performant. Notice that once I add an item to the cart, as I increase the quantity, it increases instantly, and that's reflected in our cart. As I decrease the quantity here, it decreases also instantly. You move an item, it's removed instantly, and all this is happening in the application. So we're not making external HTTP requests, and that's actually why the application is this fast, because we are doing some local state management, especially for critical data that the user is going to be manipulating and updating constantly, like the user's cart information. It's going to be walking around the application, viewing different products, adding different products, and removing, increasing the quantities. You don't want to be making HTTP requests here, because it's going to make the application very slow, and that's why we're using local state management to manage the quantity of these items in our cart. Notice everything updating in real time as we do these changes, and they also reflect here. Okay, that's the basic functioning of the application out of the way. So I'm going to now explain this a bit technically with some simple diagrams that are going to show you how I came up with all of this. So when you look at this, it's just ignore all these things you see up here for now. So what happens is, we have our front-end application here, and we have our backend, which is actually our database and our server, where we're making the HTTP request to. So what happens is, initially when the application starts, I make a GET request to get the products and the product history from the backend server. So that's why you notice here in the application, and I refresh the application, if I start everything, notice that we have all these products here and we have our product history. There's nothing in the cart. And that's actually because of this initial get request. When I get the products and the history, I populate this home page with the products and I populate the history page with the user's history. Then the only time I make a request, I see data to the backend is when the user pays for a product. So you notice, as I explained to you, it's only when the user pays, he adds some products to his cart, decides on the quantity he wants them to be. He can increase the quantities here. And it's only when the user pays for products that I make an HTTP request now and add those products to the cart. But apart from that, all these other manipulations of him increasing the quantity, decreasing the quantity, removing and adding items to his cart are done only in the application. So it's actually local state I'm managing here in the application. So the only time I make a post request is when the user pays for a product. And that's why everything is actually fast, because all the operations related to manipulating the user's card is actually handled in the context. So I created a card context in which I have different actions to add, to update, to delete, and to change the quantities of the different products in the card are actually done with different actions which I'm dispatching on the card context. And that's happening in the application in the user's browser. So I'm not making any HTTP request to manipulate the user's card. If you notice, the user's card is not even saved here in the backend. So the actual resources we track here in the backend are the products and the history. The user's card is manipulated only here on the front end, and that's why the application is fast. And that can depend on the architecture of the application. But in this case, I just decided to do that on the front end. Okay. So when you look at this, we have the state, we have some state, and we have some context. So I have some context for the card and the user's history, and we have state only for products. So when we do this initial fetch for products, we are going to store the products in a certain state in our app.js. So at the root level, at the highest level of our application, we store the state of different products. Then, since as we want the card and the history to be accessible in different pages, basically we want to be able to dispatch different actions on them. We are going to use context to manage this information for the card and the user's history. So I think with that out of the way, I can go ahead and go into code and explain exactly how this has been implemented in code so that you get a better picture of what's happening. So starting off things, I'm going to also explain the different folder structure. I think it's very important to understand how to structure your apps. So you have the different pages, the card, history, and home, which we actually see here, the home, the card, and the history. So we put them in their own folder. We have hooks. If you have, in this case, we have our useMirrored hook. So you put in the hooks folder. You have data. This one is just some fake data. This is actually what we're using as our fake REST API. Making a HTTP request to this fake JSON database here. JSON server actually is the name of the npm library I'm using to do this. So it just simulates you making an HTTP request to an existing server, but this is all happening locally on your front end. So, but the general concepts are the same. You make the HTTP request normally as if you are making the request to an existing database, an existing server. So here we have our data for products and history. Actually, this is where we store our data for products and history, but you can ignore this for now. This one was just for testing purposes so that we can actually simulate working with the REST API. The context, we have our card context and our history context as we explained. We want to be able to initialize the history so that we display on the history page and add information to the history. The card, we want to be able to add, remove, increase, decrease, and empty the card. Components, we have different components here. Principally, we notice this our card component, which displays different products in this card-like format. We have the nav bar, which is actually what is shown in all pages at the top here. We have product list. Product list is what contains these products and helps us arrange these products in this grid-like fashion. So the product list is actually what we use here in the home page to display these products in this format. And it's the same product list we use here in the card page to display many products inside this card grid. The summary. The summary is what helps us. It's a component we use so that we can grab a product. We can mention that the product has we have this certain number of products in our card, and for each product in the card, it tells you the quantity, the price, and the total cost. It's actually the same. It's actually the same component we use here in the history. If you notice, for each product, it tells you the number of products and it gives you the total cost. The only difference here is that here now we have an additional attribute which is optional, the date and the border. So here in the card, it does not have a date and border, but in the history, it has a date and border. So there are optional attributes which you pass in, and they can either be present or they can be absent. So with all that out of the way, all what we need to do now in our application is to compose these different components. So based on the page where we are in, you just throw in the different components that are necessary to make up that page, and you conditionally render different components or different HTML elements based on a certain state. So you notice that, for example, when you are in the home page, if you remove an item for your card, notice that this add button now displays. But when you add the item to the card, you have now more actions below here. And that's just conditional rendering. And I think we saw that in a previous video where I was talking about. If we go to our card.js, you see here depending on whether the product has a quantity or not, we display more actions to increase, decrease, and to remove the product based on whether it has a quantity or not. So that's just conditional range. Okay, if I head here into code, everything starts here from our index.js, as we know. If you observe here, we have this card context provider and we have our history context provider. So we actually wrap our app component, this card context provider and the history context provider, so that we can access all the data in this history and card context everywhere in the application. So that's how we started everything. You notice that, as I explained here, we make an initial get request to get all the products and the history when the application starts. So if we go to our app.js, when the application starts, in the use effect which runs when the application starts, actually call these two methods, fetch products and fetch history, to get the products and to get the history. So you notice that when I get the products, I store the products. So I set all the products, I set products and set all products in these two state variables. I save products and all products there. And for the history, when I call this fetch history, what I do is I initialize I dispatch an action to initialize the products, the history, the user's history. And that's actually because if you see here, we have a card context and a history context, and the way you interact with context. If you remember in the previous video, which I'm going to leave a link in the description, when I talked of context and hooks in the app, you know that the way you interact with a context is by dispatching actions on that context. For the history context, we just have two different action types. We have the initialize action type and the add action type. What we call the initialize is when we want to initialize the history. That's we want to save the history we got from the HTTP request into this history state in our application. And we'll call the add is when the user paid for an item. So if I go back to our architecture here, when the user will make this initial request to get the products and the history, what I do is I dispatch an initialize action, so that I'm going to initialize the history context with the history data we got from our backend. And when the user pays for an item, when the user makes a post request to pay, what I do now is I make this post request to update the user's history on the back end, so that the next time when I start the app and this initial get is done, it actually gets the updated user history from the backend. So every time the user pays, I make this post request to update the user's history, so that if the user closes the application and starts the application again and it does this initial fetch, it's going to get the updated history from the backend. When I also do this post to update the history in the backend, I update the local user history state in the application. So the user context, I update the context using this add action. So I'm going to actually add the current state of the user's card. You notice if you try to understand what's inside this history context, you notice that it's an array of objects. If you look at the history here, it's an array of objects. So this array of objects has the date when that history was actually created. So when the user add those items to his card, immediately when he pays, we add the date here and we grab all the user's card information and we save in this other property called the card. So that's why we can actually display here the user's date, and we can display all the items that are in the card based on the structure we created here. So that's all for the history. If we try to look now at the card context, the card context is actually where all the interesting things are happening. And that's because many actions are actually performed on the card. Notice that you can increase the quantity of items in the card, you can decrease, you can remove an item from the card, you can add an item to the card, and you can also empty the card. Notice that when the user pays for, like this, let me increase, let me add more items to the card. In this case, now we have 5 items in our card. You notice that when the user pays, he empties the card, and that's actually because there's also an action to empty the card here. To empty the card, so we're actually using this increase, decrease, remove, add. All these actions are actually dispatched to update the state of the user's card, the application. You notice this conditional ranging of the different product prices below here. It's actually based on the state of our card. So there's a hook I created called the useMirroredCart hook, and using hooks in React actually follow this naming convention: use and then the name of the hook you want to give. So what's the function of this useMirroredCart hook? Is actually what's actually making this application also powerful to an extent, because you notice that once you add an item to the card, the item is added to the card and all the products displayed here now show the updated state of the item. So as you increase the quantity of an item here, it's reflected in the card, and it's in the same way when you increase or decrease the quantity of an item here, it's also reflected here in our home page. So you notice that the products we grabbed initially when the application started, so all these products which were displaying when the application started and those in our cart are in sync. So there's actually some logic going on here, and that's what I expressed using this useMirroredCart hook. The way I can explain it is using these two arrays. So as I explained earlier, useMirroredCart hook takes in products, and if I go to our app.js, see that it takes in products and it takes in card. So it takes in products and it takes in card. As you see here, we have, let's say we assume that our products array is like this, and we have our card array like this. So our products array has an iPhone 9 with its price, and it has a quantity of 0. So the user has only added it to his card. And iPhone X has this price, it has this quantity of 0. So these are the products which are actually gotten from our REST endpoint from our HTTP request. And this is how the products are always going to look like. But the products which are added to the card are going to have different quantities. If the product is in our card, it means obviously that the user has increased the quantity to either 1 or above. So the quantity can be 1 or more. The user has the product in his cart. So this use mirrored cart hook, what it does is it takes in this cart and product as we see here, and what it does is it iterates through these different products in our products array, and it checks if the product is present in our cart. If the product is present in the cart, it swaps the object, the product object here with that of the cart. So for example, it iterates the first iteration, the product it grabs here is this iPhone 9, and he notices that this iPhone 9 is actually also present in our cart. So what he's going to do is he's going to replace the product, this iPhone 9 object here, with that of our cart. So it's now going to have this object with a quantity of 1 instead of a quantity of 0. It's going to move to the next, and since as this one is not present in our cart, it's going to leave it the same as it is. So that's how it permits us to be able to know. It helps us reflect the state of the products in the cart. So if it's on this product, for example, the MacBook Pro, it checks if the MacBook Pro is present in our cart, then it's going to replace the MacBook Pro with the state of the MacBook Pro in our cart. But if it's not in the cart, then it's going to leave the product the way it is. So guys, that's it for this video, and I encourage you guys to go through this code in thorough detail. Any comments, you leave them in the comment section and we are going to address them. For the support, guys, don't forget to hit that like button and subscribe to this channel as well, because more of this kind of solid content is coming up and it's only getting better. So guys, see you in the next video.